Okay, so we have seen everything. We'll proceed with the test. Okay, so what we were seeing, so this is the entire test kit. Okay, this is the entire test kit where will be, if you have what we have studied in manuals, this is your controlling unit, this is your test unit, this is your test vessel. Okay, it is made of glass or plastic fiber, whatever you say. These are the electrodes. See the shape of electrodes, it is a spherical in nature, and the gap, okay, gap should be around 2.25 mm. Okay, now this one is connected to, one wire is connected to the transformer. This also connected in transformer, as it is been taken over here. Okay, this you could see, this is a transformer beneath. Okay, from this it has been connected in this particular, and this is a controlling unit. This is the outside. Okay, as it has withstand 50 kilowatt. Okay, 50 kilowatt of breakdown it could withstand. Okay, so that's why it is kept 7 meter apart from the controlling unit. It's in a different segment, and this is in different segment. We'll do what we'll do, we'll write this entire segment, or we could assign this segment into this particular figure. Okay, so what we'll do, we'll collect the data. We'll collect the test 1 data, test 2 data, test 3 data, test 4 data, test 5 data. Okay, 5 data we will test. Okay, three times. Why 3? You could, as you could see that reason behind why to we are selecting the 3. Okay, over there we'll seek into that point, that we are why we are connecting as a 3. So how, what we will do, we'll increase. Okay, we do we are doing in this, so we have to increase this voltage. Else, while doing in lab, you will have a auto transformer. For that, you could rotate that particular point, and that instant you could see. In our lab, you have one particular mounted box. Okay, it is kept inside it. Your this transformer test kit is being placed with the electrodes. Okay, that has been connected to the two knob of the transformer, single phase transformer, that is inside that box only, right? And the controlling unit is above, it is mounted above that box. Okay, so that has a particular knobs. Okay, the high voltage indicator, low voltage indicator, and it has one uh, your memory card, or you could see the chip. Okay, at which it is not a temporary, it is a temporary thing. Okay, what happens when you are doing practical in manual sense? Okay, over here they have a particular thing to show you, but in that what happens, at certain particular point there would be a strike, and it will be that voltmeter reading come to the zero. Now, to recall that value at what particular point it breakdown happens, so there is a push button kind of system. You have to press that, so it will recall that. Okay, that is your temporary chip that will recall that this is the value where it breakdown occurred. Okay, so we'll see this segment. Okay, this is your kit. So we would be increasing one by one. Will increase the voltage. Okay, so what you have to keep in mind, you have to press this increase voltage. You have to keep, you have to see this particular segment where it is the flashover would occur, and will zoom out a little bit, and this is the graph. Okay, voltage with respect of time, at what particular time. Okay, just you see this graph, and this, and the recorded part will be kept over here. Just press. Segment. Okay, this is voltage. We'll write over here. This is 31.4. Okay, we reset it. Again, move ahead. That. Let's see when this flash is there. Okay, this particular, the another is 29.6. 29.6. Okay, again reset and again start it. Okay, this is 28. This is 28. This is 28. Okay, so we get now over here you will get the reason. Okay, it is recommended to change the fluid after 3 breakdowns. Okay, the power, the capacity of that or the property of that transformer oil that is your system uses. Okay, after 3 breakdowns. So if you want to go ahead, you could go using that, but it will be very concerned. That is why in place of your air for high power, means for high power, this power transformer is being used. Okay, in which in place of air we use this transformer oil, right? Because of this property. Now if Lotus if loses that property, there will be a major concern issue about the insulation, about the dielectric breakdown, and another problem. Okay, and even the carbon deposition is also occurred with the breakdowns. Okay, whenever there is a breakdown, so we'll see no issue on scene, but the breakdown capacity decreases. Okay, it was 28 and now it will be around 26 something. Yes, 6.6. Okay, now again if you go ahead, five. Okay, so why to go with that? Okay, why to waste the thing? Okay, this is what it has been considered. So we'll change the transformer and again we'll have a 3 sets. Okay, why we are doing, we have to provide the mean breakdown voltage. There is a 2 process, we'll see both the process to find the this. Okay, so we'll get one more data. 1.6. Five. Okay, again reset it, again increase this voltage. Okay, that is 27.4 volt. Change oil, again perform this. T1.4. 29.8. Eighty-eight point one. Change transformer oil again. We'll have test. Thirty-one point two. Thirty point one. Twenty-eight point five. Okay, no. Thirty-one point five. Twenty-nine point three. 29.3. Twenty-seven point four. 27.4. Okay, now this is all the test we have taken. Okay, now there is a one point I would be let you know. Okay, what I will tell, just follow this graph. Okay, many where you would be studying. Okay, it says a certain voltage, okay, that should withstand for particular time. Okay, so you will see if we start increasing this particular segment one by one, one by one, one by one, one by one, okay, this point, okay, this is the reason where it start. Okay, there is no effect till before 29.1 kilovolt. Okay, it is very suitable. Okay, the voltage are very suitable for that particular point. But see, from this instant, from this 29.1 means after 29 kilovolt, okay, this transformer oil start facing the issues. Okay, breakdown issues. Okay, we'll go see, it will be little bit. Okay, this particular point is your, okay, at this particular point it has been bent, and you could see this time zone. Okay, you will see that this time zone at where it uh, blocks. Okay, where it breakdown happens. Okay, see, it is going, it will increasing very, okay, it was earlier it was increasing about 1 kilovolt. Now it is been increasing with a 0.1 kilovolt ratio. Okay, so means it's starting with a frequent. You will see at a particular segment is also increasing, and this is the point where it breaks. Okay, this is the one segment, this is the withstand. You could say this particular point it occurs. Okay, this is what. Now this time duration is also a factor. Okay, is also a factor. You could see, but you have, if you have also see, sometimes this crosses that. Okay, will I will tell you the more functionality after getting 2 to 3 4 point. Okay, now let's see the time duration. Okay, we'll go with the black and see the time. Okay, for this is the time zone. Okay, now again, this for this point. Okay, this segment, okay, that is your 29. Okay, 29.7, and this particular point is your 31.2. Now let's see the third one. Okay, this is your third one, yellow one is your third one. You could see it could, okay, the time duration, okay, the time duration very high, it has been dropping at this particular point. It can sustain for a longer period of time. Okay, now again you could see these two, okay, are having of different volt. One is 28.5 and below one is 20.6.8, but the breakdown time is same. Okay, you could see at the same particular position it has been dropping. Okay, so you have to see this also. Okay, fine. So what we'll do is, we have got the data in our hand. We have the data. We have got, we have taken lots of data. Okay. We can't able to see videos. Okay. Okay. So we will move the, will help with the help of labs. Okay. Equipment. No, this was the result. These are the quiz you could attend after this completion of entire segment. You could assume, right? Like the direct strength of air at NTP is your 3. Okay, and when oil decompose, it liberates carbon. Okay, carbon and hydrogen. Sorry, carbon and hydrogen. It liberates carbon and hydrogen. Okay, the color of good transformer oil is your transparent yellow. Okay, this will be a transparent yellow. You could answer this. The direct strength of transformer oil is, you will have 50. Okay, will be, sorry, so 25 kilometer. Oh, pardon, sorry. Okay, the flash temperature of dielectric oil used in transformer. Okay, oil used in transformer for both cooling and dielectric. This is also correct. Okay, dielectric oil is your refined mineral oil. You could write this. Okay, that is your kV per mm. Okay, these are the answers that you could have. Now break down a voltage is transform of a transformer is measured when 1 point flash occur, 2 point flash occur, multi-point flash occur, 2 point, I think so. 1 point flash occurs. Okay, at one particular point flash occurs. So this answer you have to give. Now what we have to do is this data we have taken, we will find the mean value. Okay, now how to we could find? We'll open MATLAB. If you have MATLAB, you could go online MATLAB. For that you have to create your account in that, right? You could write. So we'll write code in this. We'll do in this new live script. Okay, we'll do in this live script. So you could see the values. Wait for a minute, taking time. Okay, so we'll see the value. Okay, using this and one more segment, we'll talk about that in after completion of this. Okay, this is your transformer oil testing. Okay, so what we have breakdown underscore voltages. Okay, we have this, so we'll write that in this value. So how much value it is? It's 31.4. We'll minimize, or if we could contract this one. Okay, second is your 29.6, second is your 28.0, 31.6, 29.5, 27.4, 31.4, 29.8, 28.1, 31.2, 30.1, 28.5, 31.5, 29.3, 27.4. Okay, this is the data we have taken. Now first, to find the mean is very easy, right? That is to find average. Average break to take out the average. Okay, so how you could find average? Right, we'll write A capital BV. Okay, breakdown voltage BD V. Okay, breakdown voltage. Okay, it will be there. So we'll find mean of VDV. Okay, we'll find the mean of VDV. Okay, this is done. This part is done. Right? This is fully It will run. Yes, we got the ABD value as 29.6533, right? This is the one process to find this. Another process to find is by the another segment, that is your variable distributor or distribution. Okay, this is the one way to find how to find the distribution file. Now it will be your breakdown. Okay, VP is equals to WP LIFT lift. Okay, or which value underscore V, right? This is the one particular segment to find. Okay, we'll run. Okay, it's not equal to. So it is coming as your this 30.3507 and the another is 23.3767. So it gives the more accurate part. Okay, the highest and minimum segment of this. Okay, see over here, this is a lower and this is the upper part. Okay, these 2 points are colliding in that particular segment. Okay, this and this, so this will be considered first and this will be considered second part. Now we'll also seek about how to get your uh, okay. So we'll see how to plot. Okay, we'll write the plot part. Okay, we have calculated this. So for plotting, we will write one code, that is VBPLO, sorry, VB plot. Okay, we will plot. What you have to plot? You have to plot is BD underscore V. Okay, this is what you have to plot. Now run it. Let's see what we get. Yeah, see, this is the plotting. Okay, from this plot you could see this is the line. Okay, probability, and this is the data and this is the probability. So probability is this. Okay, this one. Okay, this data is in the coming straight line. So this particular point. Okay, this is data what it has been given, that is your 30.35. Okay, this is what it has been given. Okay, this. Okay. Okay. Now, so this will see. Okay, this is a variable probability plot. Okay, this plot will give you the perfect answer. This is, if all the occurrence that is being near to this plot means it is perfect. So you could see take 31.4, and we have got mostly in 31.4. See, this is 31.4. This 31.4. It is data is given 31.2, 31.5. So this give you better value than the this this data. Okay, it gives better value than the this particular data. Okay, okay. Now this is the part. Okay, this is from this you could. So now we could end over here, and we could um, this will be about your oil testing. We have seen how to test oil, how to get the data, and how to get mean values either from this. That average mean value is getting 29.653, and from this variable probability. Okay, if this is the line, and this line, if it is coinciding, okay, if these data is very near and it's coinciding, that will be the best thing. So these are the part you could find from these two segments. These two methods you could easily find out. Okay, so we'll end this over here in this particular segment, and if we have some, we'll move into the next set of experiment, that is tomorrow on 22nd, and thereafter on 23rd as well. We'll see the another set of question on 22nd. We'll be seeing about the MATLAB and another segment, that is Ferranti effect. Okay, we'll see that Ferranti effect on 22nd, that is tomorrow. Okay.